located 7 trillion miles away from Earth, is an unprecedented discovery made by the James Webb Telescope. City lights in space. This remarkable finding has ignited a strong wave of curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, showing unusual bright lights emanating from it. What could be responsible for these city lights on Proxima Centauri b? Could this signify the presence of life beyond our planet? Come with us as we delve into how the James Webb Telescope detected these extraordinary objects in space. For years now, scientists and humans in general have carried out research to get a glimpse of life beyond our solar system. Any evidence perceived to back up this fantasy about space has been gladly welcomed over time. Recently, the scientific community got the shock of their lives when solid evidence of life forms existing in space was observed by the James Webb Space Telescope. While scouting outer space and relaying vital information back to Earth, the James Webb Space Telescope noticed strange city lights shining from the exoplanet Proxima Centauri b. Just as its name implied, the city lights looked like they lit up a distant city. The possibility of an alien city existing on the star has left scientists raving in amazement. Everyone is baffled because it seems like this is the existence they've all been waiting for. If this turns out to be true, as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space, and we're only just discovering it. Peering into the city lights that are located 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to grow the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima b exoplanet where the city lights were found as tricky. He said so because this star system, nearest to us, has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation. However, it's not so for this exoplanet, as its infrared nature is quite different from that of its host star named Proxima Centauri. This makes for a good observation by the James Webb Space Telescope, JWST, and the telescope came in handy as the right tool for the job. The JWST is able to easily detect infrared wavelengths. The characteristic heat signature of Proxima b will play a huge role in discovering the universal secrets of its atmosphere, thanks to the latest technology of infrared imaging capabilities possessed by the JWST. Scientists plan on utilizing the telescope to reveal the mystery surrounding this planet's atmospheric conditions. They also aim to use the Webb telescope to check the possibilities of residing on this exoplanet. The James Webb Telescope has an infrared sensitivity that's required to explore what happens at Proxima Centauri b's nighttime. Picking up the faintest rays of light in the cosmic darkness is usually a struggle for space telescopes, but not for the JWST, as it can pick out even the tiniest rays of light from space. It's the perfect instrument to verify if the rumors of city lights on Proxima Centauri b's surface are true or false. Every artificial illumination in the cosmos can be sensed by the telescope as long as it falls within a frequency band that's 1,000 times narrower than starlight. How does Proxima Centauri b compare to planet Earth? Proxima b has an interesting relationship between its stellar features and surface interactions. The day side of the exoplanet contains many solar panels that harness the bubbling radiant energy possessed by the star. Its spectra edge also reflects incoming light rays. At the same time, when Proxima b completes its orbit around its host star Proxima Centauri, it experiences day and night periods just like what we have on Earth, with the daytime getting high on solar heat and the evening experiencing coolness. The planet is known to have temperature fluctuations that are determined by its composition. For example, if there's no atmosphere on Proxima b, the difference between its day and night periods will be wide and far between. If there's no moderating influence of atmospheric gases and oceans, the temperature of the day side will be extremely hot like a black body, and the night side will horribly drop into cold darkness. The degree of temperature variation is a good subject for astronomers to unravel a deeper understanding of Proxima's atmospheric composition. Having an unrivaled infrared imaging capability, the JWST can efficiently examine the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around the Earth falls in alignment with Proxima b's orbital period, making complete observations of its day and night periods within 11.2 Earth days. Since it indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can accommodate life. Some good pointers in determining if there's life are the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it means that it supports habitable conditions. The process of successfully determining this requires scientists to be meticulous enough as they capture and examine light rays that move through the planet's atmosphere. This is an incredibly challenging task to undertake. Even if the JWST possesses great capabilities for characterizing planetary atmospheres, it has a different major objective. The telescope has been designed to only analyze the variations in water vapor, carbon dioxide, and methane concentration. When it comes to identifying bonded oxygen, which is a vital indicator of life, the JWST is limited in this area. Even with that limitation, the telescope still has valid reasons to search for other elements on the planet. One such reason is ozone, which gives an accurate level of vitality in the atmosphere. It's also worth noting that the James Webb Space Telescope doesn't have absolute capabilities and can only peer at a few of the closest habitable worlds to Earth. Carrying out a thorough atmospheric investigation, astronomers are now tilting toward ground-based observatories like the Extremely Large Telescope, ELT. The ELT is a telescope that has been scheduled to start operating in 2028, and it's carefully positioned to gaze deeper into the atmospheric structure of faraway exoplanets. It will produce data on these planets that will offer comprehensive and vivid insight into their level of habitability. NASA scientists and everyone else are happily waiting for the deployment of future space telescopes like these. Until then, however, the James Webb Space Telescope will continue to be a vital tool in our quest to uncover the mysteries of distant exoplanets. Even with its current limitations, the James Webb Telescope has the potential to offer deep insights that will revolutionize our understanding of exoplanetary exploration now and in the future. Scientists have an objective for future space telescopes, which is to reduce the amount of bright light coming from a planet's host star so that astronomers can clearly see the lights reflected from the planet itself. They plan to do this by using internal masks or gigantic external satellites that are shaped like an umbrella, similar to using your hand to block out rays of the sun to enable you to see an object clearer. In the bid to reduce the fierce brightness coming from the host star, future telescopes will be better positioned to study faint reflections of light coming from a distant exoplanet, allowing for a clear analysis of its atmosphere and likelihood of supporting life. Doing this comes with its own challenges, however. Scientists will have to differentiate between gases generated from life and those generated from geological processes such as volcanic activity. Astronomers aren't relenting in their bid to understand the characteristics of exoplanets, so they're more able to discover signs of life and distinguish them from false positives. The Webb telescope contains a preview of scientific advancements from the research of exoplanets, offering a sneak peek into the amazing discoveries we are yet to find. As we stretch our understanding and exploration of the cosmos farther and farther, we are better positioned to understand the intricate workings of the universe and our various roles in it. After looking through all the planets in space, scientists have yet to find any that host life despite decades of searching. The quest for forms of life on other planets continues. Are we alone in the universe? For millions of years, throughout human civilizations, humans have always wondered whether they are the only ones living in the universe. This is a very old longing that still hasn't left us in this present time. Even today, scientists have the James Webb Telescope in outer space trying to spot alien civilizations hidden amongst us while studying all kinds of planetary bodies for signs of life. At the same time, the narrative that some aliens are truly out there in the stars just waiting for humans to find them is indeed a popular narrative. To provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI, in 1984. Known as the SETI Institute, theirs is a non-profit venture that plans to sift through cosmic signals to pick up only radio signals from space. Radio signals have the ability to travel through long distances without getting scattered or absorbed like other types of radiation. Hence their decision to focus on them. Due to this characteristic feature, radio signals are more likely to be detected by the 42 radio telescopes that constitute the Stellar Allen Telescope Array found in the Cascade Mountains of California. Though the SETI Institute has religiously observed signs of these radio signals generated by alien life, there haven't been any such signals for over 30 years. Jill Tarter is enthusiastic that they'll have a positive result as they want to use the tools of the 21st century to accelerate the search. In the words of Jill, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." All of that continued until recent reports from NASA implied that the James Webb Space Telescope spotted city lights from a planet close to Earth. The JWST is the giant trump card played by humans in getting a finite grasp of the universe. It's currently the most advanced instrument in all of mankind to unearth all the mysteries of the universe. The scope is currently floating about 1 million miles away from Earth, sending accurate details about the earliest periods of the universe. It's designed to capture the previously elusive facts about space as it delivers greater clarity on the formation of space, galaxies, planets, and stars alike. Astronomers haven't failed to capitalize on the JWST's cutting-edge technologies, such as its stellar camera feature and filters to spot and analyze the delicate colors that surround celestial objects. Researchers are comfortable using the telescope to collect data about the physical properties and chemical compositions of celestial bodies located far away in the cosmos. This was achieved by isolating specific wavelengths of light. Far beyond just observing, the Webb telescope continuously gazes upon the atmosphere of exoplanets for faint traces of life, no matter how little. It has an unrivaled power to analyze the power of time and space and has revealed some of the most intriguing findings ever. One such finding is the discovery of more mass than what was previously believed to have existed in the universe. This mass has been stashed away in several giant galaxies, effectively casting doubt about the earliest layout and proportions of the universe. Humanity has since set out to explore the farthest reaches of the cosmic plane using the JWST as an integral tool for achieving this. Through the telescope, new information on isolated worlds will be documented, and more astrophysical information will be available to solve the mysteries of these planets. 20 years ago, the cosmic realm outside our solar system wasn't explored. Since that time, however, astronomers have identified over 4,000 exoplanets that orbit distant stars, showing just how far human ingenuity can go. Still, all of these discoveries are regarded by NASA as just touching the tip of the celestial iceberg. Scientists are of the opinion that in reality, there are trillions of exoplanets littered all over the cosmos that haven't been discovered yet. Not giving up over the decades, scientists are still exploring space in hopes of fishing out alien habitats in places where humans haven't ventured. They've had glimmers of hope during this quest from time to time. What exactly is the vegetation red edge? When Galileo hopped on a spacecraft traveling to Jupiter, its spectroscopic instrument unknowingly revealed a unique spectral signature that lent credence to extraterrestrial vegetation. This was the first time scientists found a biosignature that indicated the presence of life in the cosmos. This biosignature was the vegetation red edge, known as SIX. The SIX hunts down alien life differently by observing closely how it reflects light. With the help of the SIX, the James Webb Space Telescope is expected to solve the riddle of extraterrestrial environments via the careful mapping of orbital parameters of potentially habitable planets residing in the habitable zones of their alien parent stars. Once these are detected, the SIX can provide crucial evidence in the search for intelligent life forms outside the Earth, unlocking a fresh journey in unveiling the mysteries of the universe. Proxima Centauri, the closest star to Earth, has a faint glow and hosts Proxima Centauri b, an exoplanet discovered in 2016 within its habitable zone. Despite extreme conditions like tidal locking and intense radiation, the planet could potentially support life if it has an atmosphere that retains heat. The discovery has sparked scientific interest in studying its composition and potential habitability, with the James Webb Space Telescope playing a key role in this ongoing research. Speculation even suggests advanced alien civilizations might exist on the planet, adapted to its harsh environment. In recent developments, the scientific community has been abuzz with the implications of the James Webb Space Telescope's JWST findings regarding Proxima Centauri b. The exoplanet, located in the habitable zone of its star, has drawn significant interest due to the potential it holds for harboring life. The detection of unusual city lights has only heightened the excitement, suggesting that Proxima Centauri B may possess an advanced civilization, or at the very least, a highly intriguing atmosphere. The JWST's advanced instruments, including its high-resolution spectrographs, allow astronomers to analyze light in unprecedented detail. This capability is crucial for distinguishing between various atmospheric components and understanding the planet's climate dynamics. By examining the light that filters through Proxima Centauri B's atmosphere, scientists can infer the presence of essential elements such as nitrogen, carbon dioxide, and potentially even oxygen. Furthermore, the ongoing analysis of these city lights could reveal patterns or structures that might indicate artificial origins. Such findings would be revolutionary, potentially providing the first direct evidence of extraterrestrial technology. The implications for our understanding of life's distribution across the universe would be profound, shifting the paradigms of astrobiology and potentially altering our approach to searching for life elsewhere. In addition to these direct observations, scientists are employing computer models to simulate the atmospheric conditions of Proxima Centauri b. These models take into account the planet's position relative to its star, its rotation period, and its atmospheric composition to predict possible climate patterns and habitability. Such simulations are crucial for interpreting the data collected by the JWST and will guide future missions. The next steps involve not only continued observations by the JWST, but also collaborations with other space missions and ground-based telescopes. Future endeavors will aim to confirm and expand upon these initial findings, utilizing both existing and new technologies. As our observational capabilities continue to advance, the search for extraterrestrial life and the study of potentially habitable worlds like Proxima Centauri b will remain at the forefront of scientific exploration, promising exciting discoveries in the years to come.